Okay? If there's very large variation, the numbers will be very large. Now, it could be simple testing the boiling point of metal way up at 2,733 degrees Fahrenheit. Okay? And you could be looking at different metals, and they could be varied. Starting at 2,733, one could be 3,500, another could be 1,500. In aluminum could be way down at 700 degrees. And those vary drastically. You know? Drastically. And so, it's the same concept. There's a mean, there's an above the mean, there's a below the mean, and there's a measure of variation. Now we have two main measures of variation. One is called the variance, and one is called the standard deviation. Okay? Standard deviation is the one we will talk about throughout the whole class. Yes? Variance makes a little bit more sense because we talk about measures of variation and you hear the word variance and you understand it's coming together. But the standard deviation is what we're talking about. Now, how do you think we could go to the right or to the left and we could have no negative numbers? Okay? No negative numbers. You think about somebody gets a 79, somebody gets an 81, the mean is 80. Yes? Well, how could you get rid of negative numbers? Think about it. You're right. You could square the difference. Okay? So if I'm looking at the mean, I'm the mean, you get a 79. You're one below the mean. So if I look at 79 minus 80, it's minus 1. But you want to know something? I could square it. You square minus 1 times minus 1, you get 1. Yep, absolutely. Okay? Then, let's talk about the next guy. He gets an 81. Okay? 81 minus 80 is 1. Squared is 1. Okay? So you both are 1 away from the mean, just in different directions. And we continue to do this, and we can do this again and again. And you want to know something? We could take all your squared variations, your score minus the mean, squared, and we could divide by the number of people in our set, and we could have a pretty good measure of variation. But you want to know something? Just like we did in the quartiles, we're going to divide by n plus 1. Okay, n plus 1. And if you head to your book, I'm on page 107 in formula 3.9. You have your score, xi, your score, okay? So replace that. That's not xi, that's x of Daniel, x of Richard, x of you name, whoever it is. X of I, that's your score minus the mean. Okay? But I is a counter. It's not just you. It means we're going through that summation notation. I'm on page 107. Okay? Summation notation means we're counting. So I go from me to the next student, to the next student, to the next student, and on and on and on. Okay? My score minus the mean squared to get rid of the negative, then divided by the number of people minus 1. Okay? Number of people minus 1. Now, that should make sense. If it doesn't make sense, back up and listen to that again. Read through the book and listen to that again. Should make sense. Okay? We're getting rid of the negative numbers. Your score minus the mean squared divided by n minus 1. Okay? Now, that's the formula for variation. We call that variance. And we list that s squared. How that looks. S squared equals x sub I minus x bar, which we learned was the sample average, squared to get rid of the negative, divided by n minus 1. Okay? This is for variance. S squared equals variance. S squared equals variance. Now, for standard deviation, which we label by S, how can we get from S squared to S? And you notice it's there on page 107. You're just going to take the square root. Okay? Just the square root. Now, that is for standard deviation. We are going to have pictures. We are going to do this in pictures, and it's all going to be pictorial here in just a second, but these are the formulas that back it up. Okay? Don't ever forget how far you are from the mean. This is a measure of variation from the mean. The mean is central to this formula. You're taking your score minus the mean, squared to get rid of the negative, and divided by the number of items in your set. This isn't just about tests, but this is about all data sets. Now, Excel will give you the variance and the standard deviation, absolutely. But you need to know where the formulas came from. And this is where they came from. Okay? Let's look at a picture. Now, have you ever heard of grading on the bell? Grading on the bell, or the bell-shaped curve. Have you ever heard of that? Okay? The bell-shaped curve. Now, I don't grade on the bell. But if you notice, this curve should look like a bell. If you added this, we would have a bell. Okay? Now, what we're going to do is we're going to look at this, and instead of the chime being in the center, we'll have a line. This line represents the mean. Okay? So this line represents the mean. And in the bell-shaped curve, grading on the bell, that's an 80%. Okay? An 80%. Now, we represent standard deviations. Now, think about standard deviations. Standard units. Okay? Standard units. Standard units means the units don't change. They stay the same. So, we've measured standard deviation, and on the bell, the standard units are 10. So, we go in units of 10, and we draw lines. Okay? Now, units of 10, if this is 80, you add 10, that's 90. You add 10, that's 100. And you add 10, yep, 110. Okay, same thing. We're subtracting. 70, 60, 50. Okay? Now, some teachers do 75 as the mean, 85, 95, 105, 65, 55, 45, so on and so forth. But it's all the same principle. Now, this is what the picture looks like. In future chapters, we're going to call this the normal curve. Okay? We're going to call it the normal curve. But, for now, we're just calling it the bell-shaped curve. And we have the mean drawn, we have our standard deviations. So, we can think about this as parceling off our picture. Now, if the curve's not making sense, think about it being a histogram. Okay? If this was a histogram, we would have bars that kind of looked like this. Yes? We'd have bars that looked like that. Okay? That's a histogram. But in future chapters, we're going to draw a picture around it in a curve. Okay? And let me back my camera out just a little bit. Now, these standard units are drawn on the picture. These standard deviations show up on the picture. They show you. Now, if you're grading on the bell, we know 80 is the mean. You get a 90, you know you're 1 standard deviation away from the mean. See that? 1 standard deviation away from the mean. If you get 100, you are 2 standard deviations away from the mean. If you get a 60, you are 2 standard deviations below the mean. Okay? 2 below. Not -2, but 2 below. Now, what does this matter? Well, it matters a lot. There's, in your book, on page 120, we talk about the empirical rule. Okay? I'm going to erase this. I will redraw it, and I will draw this curve throughout the course. But you have the empirical rule.